Hello everyone, welcome to this video. This is about operating Cisco routers. So thank you guys for joining this video. I really appreciate it. So what are we going to be talking about this lesson? Now, firstly, I'm sorry this video has been quite delayed. So I do apologize about that. But it should be good lessons. So what we're going to be covering, well, firstly, iOS and ISXC. We're going to be looking at these two router operating systems. Just a quick discussion about what's different between them. What's iOS XE all about? Because it's similar to iOS, but there's the commands are quite similar, but there are different instances. And iOS XE is, I would say, cooler than iOS. It's got some great features. So we'll talk about that. Integrated service routers, ISR routers. You might be familiar with ISR routers, Cisco ISR routers. We'll be comparing them with we'll be talking about them, and then Catalyst Edge platform, which is like the new kid on the block, and we've got some more awesome routers that are coming out. But don't be confused. Catalyst, you might think of the class Catalyst switches, right? The 2950, the 3560. They were great switches. Sorry, but Catalyst Edge platforms is actually is quite a multifunctional router. Is more than just a router. In the traditional sense, does quite a lot. But Catalyst Edge platform, don't be confused, it's not talking about the switch range, it's something completely different. New kid on the block for this decade and beyond. So interface status codes. Now, when it comes to interface status codes, we'll be talking about the up, the up down, comparing basically line protocol status and line status and protocol status, what those different codes mean, the different variations like up, which is fine. But up, down, what does that mean? Or down, up. If your line status is down but your protocol status is up, what does that mean? Do you mean different things? The different combinations of these codes mean different things. They're indicating, they're pointing at different issues. So it's really important that we can interpret that as engineers. Then we'll be looking at the key commands to view route interface status. Ethernet interface auto negotiation. Now, you might remember auto negotiation. Not too long ago, I covered a video about this when it comes to switches. Now, when it comes to routers, it's quite similar, the process, but there's some key differences when it comes to ISXC configuration of auto negotiation. So we'll be talking about that. Router auxiliary port. The router auxiliary port, something very important for us to know about. Okay, it might not be something that you may have noticed potentially on a router before, because we normally look at the console port, we normally look at the the SFP ports, but there's this auxiliary port on the back of our router. Now, what does that auxiliary port even about? We'll be talking about that, and then finally a short practice test. So 7 parts to this lesson. So firstly, iOS and iOS XE. So iOS is the original router operating system for Cisco routers. Now, that's great. It was is even used by Cisco routers today in 2025. You'll still see routers using iOS, but you got ISXE as well now. And ISXE, it's quite similar to iOS, but it's cooler. It's got some great features to it that make it like an improvement of iOS. Firstly, now, ISXE has been out for a while. It's not something that was just released back maybe 2-3 years ago. No, it's been out since the 2000s. But what ISXE, sorry, it reduces planned and unplanned downtime. It can provide enhanced security against against attackers, and also it assists better when it comes to network automation. So it's got some cool features there. Okay, it reduces your downtime, enhanced security, and it's just with automation. That's awesome, right? That's awesome. That's what, those are brilliant features when it comes to today, when it comes to our networks, because, networks are so nowadays, the amount of bandwidth that's going through networks, and how important in today in the digital world, where we're doing everything on the internet, right? We're shopping, we're banking, we're doing we're catching up with our families as well. So if you've got networks that need less downtime, that's great. Security isn't always a thing that is so important, to be standing guard there against attackers. So that's awesome. And then automation. Obviously, automation is one of the it's not just a buzzword. Automation is something so important when it comes to modern networking. Cisco been talking about it now for several years now, actually, and Cisco Live and other events, and just generally in the Cisco world, automation is a big topic, and now AI as well. But automation is great, and if iOS XE can help us with automation, that's awesome. So this is why I think it's a lot cooler than iOS. Now, let's talk about integrated service routers and Catalyst Edge platform. So ISR, right? Okay, they're more than just routers, and that's hence why they call it integrated services. Now, they were released around in the mid 2000s, ISR routers, but now we've got this new kid on the block as well, which is the Catalyst Edge platform. So I'm just gonna have a quick sip of coffee. So the Catalyst Edge platform, released in 2020, so at the start of this decade, was a breakaway from the ISR brand. Now, it goes a step further when it comes to our multifunctionality. Remember how I was talking about ISR and how ISR is like, it does more than just what a traditional router do. But Cisco Catalyst Edge platform. I'm just going to call it CEP now. It goes a step further with that multifunctionality. It's running on ISXE, and what these they're not just traditional routers, but what these devices are doing, what these devices are called, sorry, is using the Cisco 8000 series naming convention. So this you see this Catalyst 8000. It's not don't think about the 2950, 3560. We're not talking about those. Those are switches. These are routers, but they cool routers. They do a lot more than your traditional router. So the Catalyst Edge platform, right? Again, don't be confused by the naming convention. Catalyst, yes, was a family of switches, but now Catalyst Edge platform devices. These are routers. Okay, so just don't want to be confusing these two things there. They're separate things there, but they go by the Catalyst name. So, and let's make sure we're familiar with these terms. Enterprise router, and this is a router. Sorry, this is a router that a business would use in your permanent location, an enterprise router. Okay, so that's used by a business in a permanent office location. Okay, for example, you've got a solicitor's office, right? A solicitor's firm. They have a router, which is the default gateway to the internet. That is in a permanent location. That's always there. That's what we call an enterprise router, okay? Or you've got a bank and they've got a router. They probably have several routers, but so you've got a large bank in London or New York. Enterprise routers, those are always there in those locations, used by a business for business operations, okay? In a permanent business location, that is a dedicated business location. Now, okay, so you can think, for example, let's say the Empire State Building in New York or the Shard. Those routers there, those are what would called enterprise routers. But SOHO router, small office, home office, that's what SOHO stands for. That's a router that's used in an employee's home. For example, let's say that employee works from home, or a small permanent business location that has a few workers. So we're talking about quite a small business here. For example, let me think of a good example here. But let's say you've got someone who runs like a family. Say you got a family, like a small office. Let's say that's run by a family. The office is downstairs. They live upstairs. That's a small office. Okay, like you got a small family business. For example, let's say they sell. Let's say they do some sort of consulting. Okay, small family business. That router is it's only used by a few people. It's a small business, so that's a SOHO router. Let's look at interface status codes now. Okay, the key commands we need to know about. So this table shows the different combinations of these codes. So for example, line status administratively down, protocol status down. It's important. I was trying to see if I had a screenshot to show you, but when we look at the status, in our interface status, if you were to run if you were to get the interface status of your router, and you see you'd see at one column status, another column for protocol status. Now that's great, but it's understanding what these mean. So administrative down, if your line status is administrative down, and your protocol status is down, that means your interface has been shut down by the administrator. Administrative down is different from down. Administrative down means an administrator, an engineer has gone on and typed in shutdown to shut that interface down. Now, down on the other hand, this is an indicator of layer 1 issues. One important thing to know is that the line status, right, and your line status refers to your line status is referring to a layer 1, and this is normally an indicator of layer 1 issues. This is an indicator of your layer 1 status, and a protocol status is normally an indicator of your layer 2 status. That's why a way I remember it is thinking protocol status, calling it pro 2 call status, like a pun there, but a play on words. But to understand that's an indicator of layer 2 issues. So if your line status, but remember, if your line status is down, then if you've not got layer 1, you're not got layer 2. So if your line status is down, your protocol status will automatically be down. You have to have layer 1, you have to have, cables, and you have to have that physical end-to-end connectivity, for, you have to have power, you have to have your cables connected, your interfaces, to your interfaces, your Cisco, your actual device needs to be switched on for you to have line status. So if your line status is down, that's normally an indicator of, so you get, for example, a cable not connected. Okay, the interface on the other side is down. If you got an Ethernet point to point, if you got an Ethernet circuit, maybe the interface on the other side is down, so that point to point connection isn't working. Your switch is not powered on. Okay, or there's a problem with your transmission speeds between devices. So that's normally, like I said, normally indicator layer 1 issues. So these are several types of layer 1 issues that we could be having. Now, if your line status is up, but your protocol status down, then that can be an indicator of layer 2 problems, typically related to config. So that's, for example, you got 2 protocols, right? PPP and HDLC, okay, which are used when it comes like in a point to point, like for example, when you're encapsulating a frame and you're sending it over a serial, you're sending it over a point to point link. You can encapsulate in a PPP header or a HDLC header. Now, if one side's using HDLC and others PPP, that ain't going to work. That's not going to work, sorry. So this can be an indicator of that kind of issue. Now, but if you have up status, line status up, protocol status up, that means, yeah, layer 1 and layer 2 are functioning. Happy days. Away you go. You can route packets. Awesome, right? That's great. So, collisions and late collisions. These are some issues I just want to talk about. It's late collisions. That's normally a symptom of mismatched settings, such as duplex. On either side of connection, one side using full duplex, other side using half duplex, that's not going to work. So we need to have this matching, and that's why, look, auto negotiation is great. If you're not using auto negotiation, you need to ensure that it's statically configured the same on both sides. Both sides are either agreeing to use full duplex and half duplex on each side, and when it comes to speeds as well, they need to be using the same speeds. Okay, like 100 meg each side, 1000 meg each side. Okay, now we'll be talking about how, for example, parallel detection and the logic that he uses. If one side is using auto negotiation and one side is not, that's not a good situation to be in. But for example, if that's happening, how can a router choose what speeds, what speed, what duplex to use? By doing its parallel detection process, it's sense checking. It kind of determines the speed that it thinks the router is using, and then from there, for example, if it thinks it's using 100 meg, it will choose half duplex based on its logic. But we'll get into that. Let's talk about incorrect IP addressing. That's a symptom of poor layer 3 planning and implementation, and incorrect VLAN assignments. That's a symptom of poor layer 2 implementation and planning. Okay, Remember, IP addressing, we're talking about layer 3. VLANs, we're talking about layer 2. Now let's talk. Let's focus on the commands related to router interfaces to make routers do their jobs. Routing, right? So key commands to view the router interface status. Now there's 3 here we're going to talk about, right? So show IP interface brief, show protocols, okay, type number, in square brackets. That means that doesn't mean type a number in. That means the interface type and the interface, the number, the number, that interface number. For example, gigabit Ethernet 0/0/1. Okay, that's, and then show interfaces, and then again type number, meaning insert the interface and the interface number that you want to query, that you want to find out for. So these are 3 commands, right, to view our router interface status. The first one, show IP interface brief. That'll give you a line of output, all right, for each interface, not just one line per output in total, but per interface. And that will give you you'll see IP addresses, okay. But show protocols, this one gives you 1 or 2 lines per output. Don't worry, I'll show you examples. And it will show you an IP address and the mask. Okay, it'll show you the mask, unlike the one above, that doesn't, but this one does. And then show interfaces type number, that'll give you several lines of output, and then it will give you the IP address and mask as well. So let's talk about show IP interface brief. Now, show IP interface brief, like I said, 1 line of output per interface. There's nothing related to the masks here. Show protocols, and show protocols type number, meaning interface and the interface number. So this one gives you you're getting full output here for your router interfaces, but we're not focusing on this. This wasn't even mentioned in the table, but I just wanted to show you what it looks like in full. So you see all interfaces, right? All router interfaces, you're seeing information. Now, if you were just to type in a query for a certain interface, you're getting here just 2 lines of output, but it gives you the IP address, the mask. Okay, but the mask is written in this one kind of I was expecting it when I was learning about this. I thought it'd be in like written like, for example, 255.255.25.0, right? That's what /24 is. But it's actually written in slash notation, not DDN, not dotted decimal notation. So that's something just to watch out for. Okay, but the IP address and the mask is there, and you get 2 lines of output. And then when it comes to show interfaces, and then type number, enter the interface, and the interface number, that gives you several lines of output here. Like, here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of output. Okay, we have mask information. You have the IP address and the mask there. Again, written in slash notation, not dotted decimal notation. Ethernet interface auto negotiation. Okay, so we have router or switch interfaces that support multiple. We're talking about the purpose of auto negotiation. You have router and switch interfaces. They support multiple speeds and standards. They support multiple speeds, and duplexes. They support multiple speeds and duplexes. We can run into issues if those devices have speed duplex mismatch. So we have 2 solutions: statically configure speed to duplex settings or auto negotiation. Auto negotiation is really the better option. If you don't have that on both sides, remember, you need to have auto negotiation on both sides. It's no good having on just one side. You're going to have problem. That can be a road to problems. You have parallel intersection to help there, but it's best to have it configured on both sides. Otherwise, statically configured speed and duplex settings on both sides. Remember, auto negotiation or no auto negotiation. Either you have auto negotiation on both sides, or you have statically configured settings on both sides. Now, when it comes to statically configured settings, iOS routers use the same concepts and the same commands as iOS switches. But for iOS XE, there's different commands we need to learn. So this table will talk about this. So for iOS, speed auto, duplex auto, right? You have speed auto, duplex auto. That's what we use to set the speed. That's what we use for setting the use of IEEE auto negotiation, speed and duplex. But when it comes to I6C, we use negotiation or auto, and that sets in auto negotiation for speed and duplex, and then I6C, and that disables auto negotiation on that interface. So negotiation auto, and if you want to disable it, you just use the negative no at the start. No negotiation auto to disable auto negotiation. Now remember, if you want to statically configure your speed and duplex, you need to do this bit first. No negotiation auto. You need to make sure that you disable that IEEE auto negotiation, and then you configure your speed and duplex settings manually. Otherwise, you can't do it. You have to use this first. Now, how you can view the duplex and speed settings on switches, use show interfaces status, and here you can see duplex settings, speed settings right there. Now, to understand this output, A-full, that means full duplex with, and that A means the switches has learned this value using auto negotiation. So A-full means the switch is a full duplex, switch using full duplex, but it learned to use that by auto negotiation. A1000, or no, sorry, that should be A100 actually. A100, that means using 100 meg per second speed, and that was learned by auto negotiation as well. Auto, this means the interface is going to use auto negotiation when that link actually works, when it physically works. It's not the position now to use auto negotiation, but it will when that link is physically working. So yeah, please guys, remember the rule is different when we have auto negotiation working on both sides and when we don't. When auto negotiation is working on both sides, the two devices, they will use the best speed and duplex settings, available. Don't even think about this. Do not even think about this table if you got auto negotiation. This is for parallel detection. Parallel detection, you don't need parallel detection if you got auto negotiation configured on both sides. Okay? If it's one side, then this table comes into hand. So this is for parallel detection only. You got auto negotiation one side, auto negotiation not on the other side. I don't know what's happened here. Engineer maybe not being really taking great care of the network here, because that is a very bad mistake to do. Shouldn't have this. This can cause problems. A parallel detection can help, because parallel detection is like kind of doing this sort of guesswork. Like, okay, it's sensing the speed that it thinks that all the router is using, and it's like, okay, I think you're using 1,000 meg per second. So if you use 1,000 meg per second, 1 gig per second, should I say, then its logic will be like, okay, I think you're using 1 gig per second, so full duplex. That's what I'm going to select as the duplex thing, full duplex. If it thinks it's using 10 or 100 meg per second, then it's half duplex. It's a very simple table, but just remember that we only use this for parallel detection, for situations where we have auto negotiation on one side and not on the other. Now, line status, yeah, I was talking about this earlier. I wanted to show you this earlier. This is so line status indicator for layer 1, and protocol status and protocol status, I called it here, a little pun, but I think that helps you remember that this is referring to layer 2. So line status refers to layer 1, and protocol status refers to layer 2. Now sometimes like here you see it just written status. That's line status. Don't get confused. That's we're talking about line status, layer 1. Protocol status is for layer 2. All right, nearly at the end. Router auxiliary port. So what is this mysterious port all about that I was talking about at the start? Well, this port can be used as a backup option, to connect to a switch or router, in this case router, by dialing in using a modem. Sorry, this slide wasn't written well at all. Dialing in using a modem. For in those cases you can't connect to the router, you could connect via a telephone line. If you had using a modem, you could dial into a router, and that was your backup option to get access into a router CLI. So that brings us to the end of the lesson. We've just got the practice test now. There's only 5 questions here, guys, but test your knowledge of what we've talked about. So I'm going to play the questions. Please take a moment to think about the answers and give each opportunity to pause the video, and then please play when you're ready. So, first question: what's most likely the cause behind the below router output? So here we've got a output for a router. Now, what is the most likely cause behind the output that we're getting here? So, A, serial 010 has no cable connected to it. B, the router on the other side of serial 010 is configured for PPP, but serial 010 is still using the default HDLC. C, there are no IP addresses assigned, and D, serial 001 has been shut down by the network administrator. You've got 4 options there, so please take the time opportunity to pause the video, have a think, and play when you're ready. So I'll give yourselves about 5 seconds to do that. Okay, the answer is B. So B is 010. Right, the router on the other side is most likely, this is the problem, is configured. There's a mismatch of which protocol it's using. Okay, this port is using the default HDLC, but that guy over there is using is using PPP. That's not going to work. You can't have a mismatch there. Okay, these answers are incorrect. Okay, because look, if 0010, I'm going to explain why these are incorrect. If 00010, sorry, had no cable connected to it, then your line status. Remember, I was talking about line status being indicator layer 1 issues. Having no cable connected is a layer 1 issue, so that would have been down as well. So that's why that is wrong. No IP addresses assigned. If there aren't any IP addresses assigned here, that's I mean that's not going to cause. Having no IP address assigned. These all here don't have IP addresses assigned. So that's not necessarily an indicator of why your layer 1 status is up and your layer 2 status is down. Because like for example here, look, we've got up there, and that's not going to IP address assigned. That wouldn't affect the statuses here. Okay, the IP address has got nothing to do with this, if it's assigned or not. 0001. Sorry, that should have said 010. That was referring to the interface in question. Sorry, my bad there. But 00010, that's what it was supposed to say, has been shut down by the network administrator. That is also wrong, because if that was the case, then this would all be down. Would be a line and protocol status of down. So B was the only this was clearly the answer here, but that is okay. It's most likely the issue. But you can see now why this is the correct answer, because line status is normally an indicator of layer 1 issues. That's up. The protocol status is down. So that's an indication there's a layer 2 problem there, and this is the only layer 2 problem that there is in the answers. So that's the answer, guys. Sorry about this typo there. That's my bad there. But that was supposed to be referring to this port. Let's go into question 2. So what command would you use to disable auto negotiation on iOS XE? So 4 options: no negotiation auto, disable negotiation auto, shut down negotiation, and no auto dash negotiation. And give yourselves a few seconds to pause the video, and please play the answer when you're ready. Right, hope you had the opportunity to take the time and think about the answer. The answer is no negotiation auto. So we talked about this earlier in the lesson, but no negotiation auto, that's the command you'd use to disable auto negotiation on iOS XE. Remember, it was talked about this being different from iOS. Okay, iOS, you'd use we configure our auto negotiation differently. iOS XE is different, and no negotiation auto is what you use in iOS XE. True or false? Show IP interface brief is a command you would use to view only the address but not the mask information that is configured for an interface. Show IP interface brief is a command you would use to view only the IP address, but not the mask information that's configured for an interface. Is that true or false? Please take a moment to think about the answer, and then please play when you're ready. Okay, so the answer is true. Okay, so remember I talked about that. I showed you that table and those three commands that would use to view router interface status. Which IP interface brief is the only one that would only give you just the talk about the address, but wouldn't mention the mask. The other two did, but it was in remember it was in not in a dot decimal notation. It was in slash notation. Just something to be wary, because normally you configure IP sub masks. We do it in decimal notation, but here, when you see it, it's only in slash notation. But nevertheless, this is the only command in those three that I mentioned. Sorry, my phone's just fell. It's the only command that you would not that you don't see the mask. You don't see the subnet mask. Question number 4: Why would two routers Why would two routers connected over a serial link both have interface statuses as down down? Select two answers here, so two options. Now I make this mistake sometimes. I only choose one. You have a question like this where you need to select two answers out of the list, and I only select one. For some reason I skimmed over the question too quickly. This happens sometimes, so please take time. It's two answers you need to select, so please take the time to pause the video and then play it when you're ready. Okay, so the answer is A and D. So faulty cable and one of the routers are powered off. The other two options there are talking about this is a layer 2. Sorry, that is a layer 2 issue there. Okay, that's nothing to do with the line status being down. Why would the line status be down for an HDLC and PPP mismatch? That's something layer 2 there, and one or both of the interfaces being disabled by the administrator. If that was the case, then it would say administratively down, not down. So that's the key thing to know there. Okay, so there's a faulty cable. That's something that would cause the line status to be down, and then by default, then automatically, then the protocol is going to be down. Because like I said, you don't have layer 1, you've not got layer 2. You need to have layer 1 to have layer 2. If one routers are powered off on that serial link, then yeah, definitely that's layer 1 issue, and that's going to cause the line status to be down, and then the protocol status would also go down. So those are the two clear reasons there, clear answers for this interface status of down. So question number 5, last question: which type of router port is commonly used to connect to an external modem so that engineers can remotely dial into the router? So you got console, serial, auxiliary, and no such port exists. So please take time, pause the video, and play it when you're ready. Give yourselves a few seconds to do that. Okay, so the answer is C, auxiliary port. Okay, so that is the short practice test there, and that brings us to the end of the lesson. So thank you so much guys for watching. I hope you found this video beneficial. If you did, please like, share, and subscribe. It does help me out a lot, and I always appreciate it. So thank you guys, take care, goodbye.